Hello students, welcome to Narayan College online classes. So in the last video we have discussed up to the 32nd question. Coordinated bond, N2O5 will have coordinate bond. You know nitrogen, then I made a small mistake. Nitrogen usually forms 3 bonds. Nitrogen can form maximum how many bonds? 4 bonds. That too, it donates its lone pair of electrons. Clear ma? See next one. 33, question number 33. A coordinate bond is formed when an atom in a molecule has coordinate bond. Coordinate bond means what? One atom should donate pair of 2 electrons. Means pair of electrons to other atom, but both will share. So means the atom should have one or more unshared pair of electron because it has to donate pair of electrons to others. So that's why option 4 is the correct one. Which has coordinate bond? 34. Question number 34. Clear? Which has coordinate bond? I said how to do this is coordinate bond. Clear? Write the first central atom and after then surrounding atoms, and first try to fulfill the central atom octet. Clear? So that is the thing. So first one, SO3 2 minus. SO3 what it is here? 2 minus. Clear? So what is the central atom here? Sulfur is the central atom. Sulfur belongs to which group here? 6th group. Valence. How many valence electrons are there in the sulfur? You know 3s2, 3p4, 6 electrons. Write those 6 electrons around the here. What it is here? Sulfur. 6 electrons around the sulfur. You write it that way. So 3 oxygens are there and put here 3 oxygens around the what it is here? Sulfur. Okay. Now, oxygens, sulfur and oxygen, you know, both will have the same number of electrons. Clear? Here also 6 electrons. Clear? First of all, what you have to do? Fulfill the. This is you have to write. SO3 2 minus. Clear? Minus 2. Formulas of that is lateral chemical. Clear? Now this is the. Now we have to complete the what it is here octet of sulfur. That is the first we have to do while calculating the dative bond. Sulfur is having how many atoms here? 6. 6 means, and it will make it will use means oxygen will give 2 electrons and sulfur 2 electrons. Then what will happen here? 2 bonds will form. Means now these 2 electrons also belongs to what it is sulfur. Sulfur is having now how many electrons? 8 electrons. 2, 4, 4 plus 2, 6, 6 plus 2. What it is here? 8. Clear? So sulfur octet is completed. Now, will it form? Here also 2 electrons are there. Will it form here bond with this oxygen? No, won't form. Why? If it form, sulfur is having how many electrons? 10 electrons. 1, 2, 3, 4. This is also belongs to what it is? Sulfur. So 5 means 10 electrons. So that's why it will not make any covalent bond with these atoms. Then what it will do? Because oxygen here 6 electrons, so it need 2 electrons. So it donates the pair of electrons to oxygen. Clear? So now oxygen also fulfill the octet. This oxygen also fulfill the octet. Sulfur also fulfill the octet. So how many coordinate bonds are there? 2 coordinate bonds. Clear? 2 coordinate bonds. So that's why this molecule will have coordinate bond. CH4. CH4 will have coordinate bond. You know methane. Methane, what is the formula? This is the methane formula. Is there any coordinate bond here? No. In the same way, ammonia. Ammonia you already know. Clear? What is the ammonia formula? This is ammonia formula. Clear? Next one is CO2. C double bond O and C double bond. Is there any coordinate bond here? No coordinate bond. So that's why. And here in this molecule only coordinate bond will be present. Suppose if they give NH4 plus, if they give NH4 plus, nitrogen will form how many bonds here? Nitrogen will form 3 bonds. Maximum how many bonds it can form? 4. That too, if it donates a pair of electrons. This is a coordinate bond. Then you will get the NH4 plus. Clear? So that is. So now your option should be option 1 is the correct one, 34. Next one, 35, question number 35. Same. The compound containing coordinate bond is, means here they have given some compounds. You have to say coordinate bond. Which compound has coordinate bond? Clear? So as I already said, first what they have given here, O3, and second one is SO3, and the third one is H2SO4. In which compound coordinate bond is present? That you have to identify. Clear? Simple what I said, trick here. First write the central atom. Central atom electrons you write. Then after that surrounding atoms. So O3, what is the central atom here? Oxygen. Oxygen belongs to which group? 6th group. 6th group means how many electrons we have to write around the oxygen? 6 electrons we have to write. I am writing here 1 and here 2 and here 3. 3 electrons I have written, means 3 pair I have written 6 electrons. Now, and here 1 oxygen and here 1 oxygen. Oxygen, you know, oxygen also belongs to what it is? 6th group only. Shall I write here? Oxygen also belongs to which group? 6th group. Here also oxygen is belongs to 6th group. Clear? Now you see, the central oxygen is what it is. This is the central atom oxygen, and it has to fulfill the octet. But here how many electrons are there here? Total 6 electrons. So that's why, and it will use the this oxygen will give the 2 electrons. Then it will form a bond. This is a bond. Clear? Then this oxygen is having how many electrons? 1, 2, 3, 4. 4 pair of electrons. Total how many? 8. 8 electrons central atom. It completes its octet. Clear? So now, will it form any covalent bond with this oxygen? No, it cannot form. Suppose if you write here 2 electrons, if it form here another 2 bonds, oxygen it exceeds its octet. See here. 1, 2, 3, 4, 5. Total how many? 5 pairs means 10 electrons. So that's why it won't form here any covalent bond with this oxygen. So that's why. But oxygen here 6 electrons. They need 2 electrons. It donates this pair of electrons. That we will call as a dative bond. Clear, my dear? So this is one dative bond. In the same way, SO3. SO3 means what is the central atom? Sulfur is the central atom. And here oxygen, and here oxygen. What we have to do first of all? First of all, write the central atom valence electrons. Sulfur valence electrons, how many? There are 6 valence electrons in the sulfur. Oxygen will have how many valence electrons? Same. Sulfur and oxygen also will have the same number of valence electrons, that is 6. Now, sulfur is not attended octet, so that's why. And what it will do? And it will form a bond here. Means these electrons, oxygen will give 2 electrons to sulfur, and this sulfur use 2 electrons, oxygen 2 electrons. They will make a double bond here. Now this sulfur is completed octet. 1, 2, 3, 4, total 8. 8 means it will not form any covalent bond here. If it form covalent bond, its octet will exceed. So that's why what will happen? It donates its pair of electrons. How many coordinate bonds are present here? There are 2 coordinate bonds. Clear? In the same way, H2SO4. H2SO4 means what is the central atom? Sulfur. And here you know oxygen and oxygen, oxygen and oxygen and hydrogen. Because hydrogen you have to attach to the highly electronic atom. Right? Same way here. You know, I am writing here 6 electrons around the what it is one central atom. Clear? And you know, in this case, oxygen also having the oxygen also, you see here and here, oxygen is also having what it is 6 electrons. 1, 2 means 4 electrons, 5 and 6. I am writing in this way. Clear? So this is 1. And the hydrogen, you know, it is having 1 electron. Clear? This sulfur also having 6 electrons. Whatever it may be, you know. 1 electron, 1 electron. Hydrogen give 1 electron, oxygen give 1 electron. 1 bond. Sulfur 1 electron and oxygen 1 electron. 1 bond. Sulfur electron 1 and this is. And here also 1 bond. Clear? See now, around the sulfur how many electrons are there? 1, 2, 3, 4. Clear? 1 pair, 2 pair, here 1 pair is there. This is 1 bond means how many electrons? 2 electrons. And here also 12. Means total how many electrons are there? 8 electrons. Means sulfur, it completes its octet. then it will form any other covalent bond here? No. So this oxygen having 6 electrons, this oxygen also having 6 electrons. So this sulfur donates a pair of electrons, and those will be called as a dative bond. So that's why, and all compounds will have the what it is known as dative bond, and that is your answer. Option 4 is the correct one. Clear? Now 36. So coming to the question number 36. Clear? Which molecule has a dipole moment 0? Clear? So we have already discussed carbon dioxide. Clear? Carbon dioxide. The dipole moment direction of oxygen is this side, and this is both are in opposite side and same magnitude. So that's why dipole moment will be 0. I already said if molecule is having regular shape, and those molecules will have the dipole moment 0. So your option 2 is the correct one. Clear, ma? So coming to the question number 37. In the following, which have 0 dipole moment? Clear, ma? 0 dipole moment. I already said dipole moment is 0 for the regular geometry molecules. Clear, ma? The first one is boron trifluoride. You know, boron trifluoride. Clear, no? So boron trifluoride is having which shape? Regular shape. Why? It doesn't have any lone pair. It doesn't have any lone pair means it is what is regular shape. If it is regular shape, you know what is the hybridization for this one? sp2. Is there any lone pair of electrons here? There is no lone pair of electrons. Regular shape. Regular shape means dipole moment will be what is 0. Because you know that dipole direction. This is the direction and these are the directions. What is the resultant? This is the resultant. Both will be opposite and same. So it will be 0. In the same way, CCl4 also we have discussed mu is equal to what it is 0. It is a tetrahedral shape. There is no lone pair of electrons. And BeCl2. BeCl2 also what is 1? This is Cl and this is Cl. So what will happen? And this is dipole moment direction always towards the highly electronegative atom. So both are opposite and both are chlorine. So that's why magnitude also same. So mu is equal to what is 0. So that's why all of the above is the answer. So which one has largest dipole moment? Clear? So and you know CCl4 is at 0. HCl and HI if you take HCl and HI, you know these are diatomic molecules. I already said for diatomic molecules. So dipole moment is directly proportional to the electronegativity. So which one is more electronegative? Chlorine is more electronegative than the iodine. So HCl is having high dipole moment than HI. But if you take CH3Cl will have high dipole moment than the HCl and HI. Why? Because here dipole moment will be added. Cl, H and H. This is dipole moment direction and this is dipole moment direction. Clear? So in this one resultant will be here and these two resultant also will be added. Here more dipole moment. So this is the answer. So last one what it is one here? CCl4 will be 0. So now your option should be, so if you want to write here, this is dipole moment value is 1.14. This value is 1.08. And this is 0.42 and this is values are 0. Values not required, just concept is required. Clear now? So this is about the question number 38. And 39 if you see, the unequal sharing of bond pair of electrons between the two atoms. Sharing of electrons unequally. You know, suppose A is there and B is there. And sharing equally, this is, and sharing unequally means it is this pair of electrons are moving one side of atom. Suppose any one side it is there. Sharing means, equally sharing means it will be there in the middle. Unequally sharing means it will be there in the towards the more electronegative atom. When it is there more electronegative atom, one is gets the negative charge and this is gets losing electron. A is losing electron means positive, B is gaining electron means negative. So what is created here? Dipoles are created. Poles are created. This is one pole and this is one pole. That is dipole is created. Clear? So option 1 is the correct one. 40. Which of the following has least dipole moment. Which of the following has least dipole moment? If you write the structures, by seeing the structures, you can easily say the answer. If you take the water, you know how many lone pair of electrons are there on the oxygen one? 2. Now remember here, nitrogen will form how many bonds? 3 bonds. Oxygen will form how many bonds? 2 bonds. Carbon will form 4 bonds. And here, next halogens will form 1 bond. Clear? And it is forms 1 bond, and at that time it will have 1 lone. Means next one is fluorine will be there. Fluorine will form 1 bond. Clear? Carbon, when it forms 4 bonds, it will not have any lone pair of electron. Oxygen forms 2 lone pair. I will write very clearly here. So F is there, fluorine 1 bond. After that, oxygen will form 2 bonds. Nitrogen will form 3 bonds. Carbon will form 4 bonds. When fluorine forms 1 bond, it will have the 3 lone pair of electrons. Because fluorine, what it is, 2 has 2p5. So 2p5 means here 2 electrons. And here how many electrons? 1, 2, 3, 4, 5. This is unpaired electron involved in the bond formation. 1 bond forms. Remaining 3 are what it is, lone pair of electrons, that is. When oxygen is there, oxygen what it is, Np4 means here 1 electron will be there. It is 2 unpaired electrons are there, and these 2 unpaired electrons involved in the 2 bond formation. Clear? Then how many lone pair electrons will be there on the oxygen? 2 lone pair. If nitrogen forms Np3 means this is nitrogen will form how many bonds, here? 3 bonds, because 3 unpaired electron. When it is forms 3 unpaired electron, it will have 1 lone pair. Carbon is having what it is, carbon. This is 1, 2, 3, 4. An excited state. All are which one? Unpaired. How many bonds it will form? 4. Is there any lone pair? No, that is thing. When fluorine forms 1 bond, halogens will form 1 bond. Not fluorine, halogens you can say. Fluorine, bromine, and iodine. And halogens will when form 1 bond. How many lone pair will be there? 3. And oxygen will form 2 bonds. Then how many lone pair will be there? 2. Nitrogen forms 3 bonds. Not only nitrogen, any element in the 15th group, nitrogen, phosphorus, arsenic, antimony, and bismuth, when they form 3 bonds, it will have 1 lone pair. 14th group elements, when they form 4 bonds, that doesn't have the lone pair of electrons. Clear? So that's why if you keep on this in your mind, then it will be easy. Oxygen is forming how many bonds here? Oxygen is forming 2 bonds. 2 bonds means what it is, 2 lone pair of electrons will be there. And the next one, which question it is? See the 40th question. Ethanol. Ethanol means C2H5OH. Oxygen is forming 2 bonds, 2 lone pairs. Clear? Ethane. Ethane means CH3. Clear? Means this is H, and this is H and H. Clear? Next one. Ether. Ether means any ether. Suppose I will take CH3O, CH3. How many lone pairs are there? 3 lone pairs. Clear? Is there? This is regular geometry. It doesn't have any lone pair of electrons. There is no lone pair of electrons. So all are bond pair, means it will have which shape? Regular shape. And it is a regular shape, and dipole moment will be 0. Mu is equal to 0. In all cases, mu is not equal to 0 because it will not have the regular shape. When they are not having regular shape, dipole moment is not equal to 0. That is the answer. Except one condition, that is, a square planar. Whenever that is 4 bond pairs and 2 lone pairs are there, in that case only, yes, lone pair also there, but mu is equal to what is 0. That I already mentioned. This is only the exceptional case. If because square planar, this is the square A and here B and B and B and B, lone pair and lone pair, all are in opposite direction. This is opposite direction. These two are opposite direction. Lone pair also opposite direction. Except this case, if any case lone pairs are there, definitely the molecule doesn't have the dipole moment 0. So that does not have the dipole moment 0. Clear? So that is 41%. BF3 and NH3 both are covalent only. Boron trifluoride, clear ma? And another one is NH3. Both are having covalent bonds only. Clear? Because both are, you know, this is non-metal, 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 non-metal. Non-metal, non-metal bond is which one? Covalent bond you already know. But BF3 is a non-polar and NH3 is a polar. I already mentioned previous, you see. If dipole moment is equal to 0, that molecule we will call as a non-polar. And mu is not equal to 0, then those molecules we will call as a polar. Clear? Both are covalent only, but this is a non-polar, this is a polar. Why they are asking? Why? Boron trifluoride, I already mentioned boron trifluoride. Mu is equal to what is 0. NH3, nitrogen forming how many bonds? 3 bonds. When nitrogen is forming 3 bonds, it will have one lone pair. If it is having lone pair, will it have the regular geometry? No. If it is not having regular geometry, not equal to 0. If it is 0, so that's why it is a non-polar. It is a polar. That is only the reason. So your reason is bond has no dipole moment, and the second one has a dipole moment. Option 2 is the correct one. Option 2 is the what it is here? Correct one. Next one, 43. Which one of the polar among the molecule? If they mentioned polar, you have to see what is the dipole moment. Why? Because I already said the polarity of a molecule is measured by the dipole moment. So that's why whenever they are giving polar, you have to see which one here, dipole moment. So just now only I mentioned here, mu is equal to 0, non-polar. Mu not equal to 0, polar. Means they are asking which is a polar. Polar means what is not? For which, indirectly they are asking for which molecule dipole moment is not equal to 0. That is CO2. I already mentioned CO2 dipole moment what is not? 0. CCl4. Dipole moment what is not? CCl4 means CO2 means you already know. This is CO2 and this is dipole moment direction, both are cancelled. 0. CCl4, tetrahedral, Cl, regular geometry. Is there any carbon is forming 4 bonds? Carbon doesn't have any lone pair. Regular geometry, mu is equal to 0. CH4 also regular geometry because carbon is forming 4 bonds. It doesn't have any lone pair. Regular geometry means mu is equal to what is not? 0. Clear, what is? In the same way, H2O. H2O means here water molecule. Water molecule is having, when oxygen is forming 2 bonds, how many lone pair it will have? 2 lone pair. It is not a regular geometry. So mu is not equal to 0. For these three molecules, mu is equal to 0 means these all are non-polar, and this is a what it is polar. So that is your option. Clear? Next one, 43. If the electron pair forming a bond between two atoms A and B is not in the center, clear? Means A and B, the bond is formed by these two electrons, but these two pair of electrons are not in between the center. I already said, if they are in between the center, it is a non-polar covalent bond. It is a what it is here? Non-polar covalent bond. Because, and both are means when it will happen, both A and B atoms are same. That time, and you know, it is not more, any one of these is not having any high electronegativity. Both are having same electronegativity. That time, the lone pair of electron is present exactly in the center between the two atoms. But if B is more electronegative than A, then these bond electrons are very closely towards high electronegative atom. That is a B. That is they are asking. They are not in the center and they are moving towards any one. So then the bond is which bond this is? When this bond will, the bond electrons will move towards somewhere, because if that is more electronegative, so that's why these electrons are close to B. B is gaining electron, negative charge. This is what is not losing electron, positive charge. So that's why the bond is a which bond? Polar bond. Clear? No? Poles are generated, so that is a polar covalent bond. This is non-polar covalent bond. Which of the following liquids is not deflected by non-uniform electrostatic field? Non-uniform electrostatic field means, if we keep the molecule, it has to move. In the electric field we will apply, one is positive and another one is electric field means this is the electric field. Suppose I am using a positive and negative poles. Clear? Now, which compound not deflected by a uniform electric field? It is one compound will be there. That compound will not move towards the negative pole or towards the positive pole. What is that molecule they are asking? You already know that. Here, when we keep the electric pole, if the molecule is a polar, suppose just assume I have applied here electric field. This is a positive charge and this is a negative charge. If the molecule is there, positive and negative. If the molecule is a polar, suppose AB I have taken one. If this molecule is a polar means what it is one? And these bond electrons move towards the higher electronegative atom. A gets the positive charge and B gets the negative charge. If they are in the form of poles, means positive and negative, this negative charge will attract towards positive pole, positive charge attracted towards negative pole. Clear? Means if the molecule is polar, then it will move towards the respective opposite charge of the electric field. But which is not deflected. Not deflected means what? It should not be a polar. If it is a non-polar, then poles will not be generated. Non-polar poles will not generate. Poles not generated. It will not move towards the positive or towards the negative. Means indirectly they are asking what it is here. Which one is a non-polar? They are asking. Non-polar means which one is having the dipole moment 0. Indirectly they are asking the question. You see, these are the competitive. You see, this is directly they can ask which one is the polar they can ask. Polar means you will see directly dipole moment. Yeah, this dipole moment is not equal to 0, so it is a polar, you will say directly. But sometimes they will not give questions directly. See, like this they will give. They are putting one electrostatic field means positive and negative charge, which will not be deflected. They are asking. Which is not deflected means if poles are there, deflected. Poles are not there, not deflected. Not poles means non-polar. Clear? Which molecule is non-polar means I already mentioned hexane. Previous only mentioned it is a non-polar. So that's why hexane is a, for hexane dipole moment will be 0 because hexane means what is it? CH3, CH2, 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 1, 2, 3, 4, 5, and here what is 6. These all are, in all cases carbon is having 4. What is my valency? No lone pair. So that's why it is having which geometry? Regular geometry. Regular geometry means mu is equal to what is 0. Mu is equal to 0 means it is not a polar. If it is non-polar, then poles will not be generated on the molecule. If poles not generated, it will not deflected. That is the option. Clear? Next one. Which of the following is a non-polar? Non-polar when we will get one? If electronegativity difference is 0, then it is a non-polar. Suppose hydrogen is there. Is it polar or non-polar? Non-polar. Why? Because both are same atom. This lone pair of electron means this bond pair of electron exactly present in the center. Clear? So that's why what is the option here? Cl2 will be the option, and this is about the level 1. Then we will go for level 2. So here now we will start level 2. But you see in the level 2 some irrelevant questions are there which are not in the previous syllabus. And these some questions are there not in this chapter, but it will come in the some other chapters. Clear? Like in the second year some questions are coming in the next 13th group and 14th group, which we have not covered till now. So from those chapters they have given some questions here. So those type of irrelevant questions I am skipping here, and there we will discuss. Clear, my dears? Because if I discuss also you cannot understand. Clear? So which are related to this chapter, those questions I will discuss. Clear? No? See, first question I am skipping because it is not belongs to chemical bonding here. Clear? No? Next one. Coming to the question number 2. So many 3-4 questions are there which are not related to this chapter, and those I will skip. And because don't think that they are not belongs to chemistry. They are belongs to chemistry, but it will come in the, some questions will come in the second year, and some questions comes in the first year only, but we have not covered till now those. Not yet covered. Clear? So that is. So see the question number. Which of the second question? Which of the following molecules are expected to exhibit intermolecular hydrogen bonding? I already mentioned here hydrogen bonding at the end of the chapter. Clear? We have two types of hydrogen bonding. One is intermolecular hydrogen bonding, and another one is intramolecular hydrogen bonding. Intermolecular means among the molecules, one molecule will be there, another molecule and another molecule. Among those molecules, hydrogen bond will be formed, and those molecules can be same or different. Clear? And that is intermolecular. Intra means within the molecule. Hydrogen bond is formed within the molecule, and those type of hydrogen bondings we will call as a intramolecular hydrogen bonding. Clear? So now, which of the following molecules are expected to exhibit intermolecular hydrogen bonding? First one, they have given acetic acid. The formula of acetic acid is CH3COOH. This is the acetic acid. If I write here, what is the structure? This is C and double bond O and OH. I will write another same acetic acid OH, and you know here there will be a double bond O, and here CH3. Here these are what is one. One is acetic acid, another one is acetic acid. Now, is there any chance of hydrogen bonding here? Yes, here hydrogen bonding chance is there. Why? Hydrogen bond takes place between the hydrogen and the highly electronegative atom, like fluorine, oxygen and nitrogen. But this hydrogen should attach to the highly electronegative atom only. All hydrogens will not participate in the hydrogen bonding. The hydrogen which is attached to highly electronegative atom, like what it is one? Fluorine, oxygen, nitrogen. In some cases organic compounds, and some cases we will say chlorine also. Chlorine, sulfur will come, but those are very minor. Clear? These three. So that's why this hydrogen and highly electronegative atom, there will be a hydrogen bonding. And here also what it is one? There will be a hydrogen bonding. Because hydrogen which is attached to highly electronegative atom, and nearby hydrogen highly electronegative atom is there. Hydrogen bond is. It is inter or intra? Inter. Why? This is one molecule. This is one molecule. This is intermolecular hydrogen bonding. So that one. And orthonitrophenol. Second one, what they have given here? Orthonitrophenol. We have discussed already. This is in the example. Orthonitrophenol. Phenol means OH I mentioned. You see here? Is there any chance? Yes. Hydrogen, oxygen. Hydrogen highly electronegative, but hydrogen is also attached to a highly electronegative atom. So that's why here there is a chance of hydrogen bonding. But this hydrogen bonding is what we will call. It is inter or intra. Intra, within the molecule only it is formed hydrogen bonding. So this is intermolecular, and it is what it is not. Intramolecular. Intra means within the molecule. Clear? Next one. Metanitrophenol. Ortho means 1 and 2nd position. Meta means 1 and 3rd position. Clear? So this is N double bond O, and here what it is? OH. Is there any chance of intramolecular here? No. Why? Why? Because you know in this case the distance is increasing from the. This is 1, 2, 3. This position, 1 position, 3 position substituents are there. That we will call as a meta positions. 1 and 2 positions ortho. 1 and 4 position para. Clear? In the organic we will discuss that one. So now, here there is no chance of hydrogen bonding, because hydrogen bond to form, both the atoms must close to each other. But here they are away from each other. Away from each other means, if I write another compound here, another compound, clear here? So what I will write? In this case, I will write here NO2. Clear? So this is NO2, and here 1, 2, OH I will write this is OH. Then what will happen, you see here, there is a chance of hydrogen bonding. This is what is here, hydrogen bonding. It will involve in the intermolecular hydrogen bonding. Clear no? So that is boric acid, orthoboric acid, H3BO3. Clear no? So this is orthoboric acid. What we will call this is H3BO3. In this case also, if I write another H3BO3 and here OH and OH, if I write here another H3BO3, OH and OH, and what is no OH? Here there is a hydrogen bond. If I write here, there is a hydrogen bond. In this case also, what is no oxygen and hydrogen bond. These all are which one? Intermolecular. This is also what it is here, inter. This is also what it is inter. This is what is intra. So that's why 1, 3, 4 are form involved in the inter, and second one is involved in the intra. So that's why what should be your option here? Option 3 is the correct one. Clear one? Next one. Question number 3. Clear one? In which of the dimerization process the achievement of the octant is not the driving force? Clear man? See the first one. AlCl3 dimer. Dimer means one molecule and another molecule they form. This is the dimer. Dimerization of two molecules are involved here. See man? In the same way, AlCl3. AlCl3. What is the shape of this molecule man? Al, and here there will be a Cl and Cl, and I will write Cl here. And what is this? Complete octant or incomplete octant? It is incomplete because aluminum, around the aluminum, how many bonds are there? 3 bonds. 3 bonds means how many electrons? 6 electrons means incomplete octant. Incomplete octant. So that's why they try to complete the octant. So that's why they involve in the dimerization. Two molecules will involve. See here, aluminum, here Cl, and here what is Cl. Then what happens? You see in this case. You know that halogens are having, when you know halogens, when they form one bond, how many lone pair will have? 3 lone pairs. So that's why here these one lone pair they donate to the aluminum. Why? Because aluminum previous, before forming this bond, around the aluminum 6 electrons are there. Now it is giving 2 electrons to this one. So aluminum attains the which one? Octant. This is also same. It gives the, this is, now it is octant complete. So that's why they involved in the dimerization. This we will call it what is dimerization. 2 AlCl3. AlCl3, AlCl3. So this is the dimerization is the driving force here to complete the octant. If there is no dimerization, incomplete octant. Clear one? That is the first one. And second one also, BeCl2. BeCl2. It is a gas. BeCl2, if you write commonly, Be and Cl is completed octant one here? No. How many bonds are there here? 2 bonds. 2 bonds means how many electrons? 4 electrons means incomplete octant. It is involved in the incomplete. So that's why they involved in the dimerization to complete its octant. See now, beryllium, and here what it is now? Chlorine, and here beryllium, chlorine and chlorine. Then what happens? You see chlorine, it donates one lone pair of electrons, and another chlorine also donates another pair of electrons. Same, if I write another one, here also chlorine and chlorine is there, and beryllium, then also it will give. So that's why. Now what happens here? They attain. Now how many bonds? 1, 2, 3, 4. This is also 1, 2, 3, 4. Keep on writing like this dimerization. Then what you will get here? It is involved in the dimerization. When it is involved in the dimerization, it attains the what it is here? It attains the octant. Now octant complete. It octant what it is here? Complete. So this is. So that's why they involved in the dimerization. Next one. ICl3. ICl3 means, you know, this is I, and here what is Cl, and Cl, and here what is Cl. So now this is forming 3 bonds. Totally iodine means halogens will have. What is the electronic configuration? Electronic configuration NS2 NP5. So this is 2 electrons here. This is how many electrons? 1, 2, 3, 4 and 5. It is forming how many bonds? 3 bonds. But here what it is? 1 electron only there. So next p orbital will come. Next d orbital will come. They jump one of the electron here. Then how many electrons are there? 3. So it is forming how many bonds? 3 bonds. How many lone pair of electrons will be there? There are 2 lone pair of electrons. Clear? So it exceeds octet, but it involved in the dimerization. It involved in the what it is here? Dimerization. So I and here I and there will be a Cl and there will be a Cl, Cl and Cl and here Cl and Cl. They involved in the what it is dimerization. Why they involved in the dimerization? Clear? Why? Because you see here it is they are stable when they are in the dimerization. But here also complete octet. Here also what is not? Octet is complete. More than it is extended octet here. Extended octet. And here also what is not? It is complete octet. But they are dimer not to get the octet. It is not a driving force. But in this case, it is incomplete. So that's why they are involved in the dimerization to complete the octet. But in this case, and it is not. It is more than 10 means 10 electrons it is having, so it is not an incomplete, it is a complete octet only, and greater than octet, but they involved in the dimerization because to the stability. It is not the driving force, dimerization for the octet. So option C is your correct answer. See the next question, fourth question. Question number 4. Tetracyanometane. Methane formula H and H. Tetracyanometane. Instead of hydrogens, you have to put the cyano group. Cyanide. Cyanide group means and C triple bond. Yeah, this is the cyanide. Clear? So now this is the one. What they are asking, ratio of sigma and pi bonds in the order. Clear? So in this one, how many sigma bonds are there? How many pi bonds are there? We have to discuss. Clear? Sigma bonds means this is 1, 2, 3, 4. 4 sigma bonds are here, and here, and triple bond is there. Triple bond is there. 1 sigma, 2 pi. You already know that is. Clear? So that's why. Total how many sigma bonds are there? 1, 2, 3, 4. 4 sigma, and in this multiple bond, 1 is sigma. 1, 2, 3, 4, and 4 plus 4. Total 8 sigma. How many pi bonds are there? 2 pi. Here 3 bonds means 1 sigma, 2 pi. Here 2 pi, 2 pi, 2 pi, 2 pi. Total how many 8 pi bonds are there. Now they are asking ratio of sigma and pi. Sigma and pi ratio is equal to how much? 8 divided to 8. That is what is 1. Next one. Second one. Second one, carbon dioxide. Carbon dioxide means what CO2. You already know the structure. How many sigma bonds are there? 1, 2 sigma bonds. And how many pi bonds are there? 1 double bond means 1 sigma, 1 pi. Here pi and here pi. 2 pi. What is the sigma by pi ratio? 1. And next one, third one. Third one, what is here? Benzene. Benzene you already know. This is benzene. C6, H6, hydrogen, 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 and hydrogen. CH bonds. These all are sigma bonds. 1, 2, 3, 4, 5, 6. 6 sigma bonds here. And now these all are 1, 2, 3, 4, 5, 6. 6 sigma bonds. Clear? Total how many are here? 12. But here 1 double bond means this is a sigma, this is a what is pi, this is a pi, this is a pi. And pi bonds how many? 3. So what is the sigma by pi ratio here? 12 by 3. And what is 4? And what is the last one here? 1 comma 3. 1 comma 3 butadiene. This is CH2 and here CH double bond CH2. This we will call as a 1, 2, 3. 1 comma 3 di means butadiene. In this one, write how the structure: hydrogen, hydrogen, double bond, C hydrogen and C hydrogen, double bond, C hydrogen and hydrogen. Sigma bonds you calculate 1, 2. 1 double bond means 1 sigma bond, 1 pi bond. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sigma bond. Pi bonds how many ma? 2. So sigma by pi ratio how much ma? 9 by 2, 4.5. So which one? This is D. D is having the highest. And after that what it is ma? 3. C is having the highest. A and B, 1, 1 only. A is equal to B and B is equal to A. This is the answer. So what should be the answer here? Option 1 is the correct one. Clear? Next one. See the question number 5. Which of the following bonding best described in the bond within the layers of the graphite? Graphite I already mentioned. Graphite is formed by the carbons. Carbon-carbon bond, what we will call covalent bond only. So non-metallic covalent bond. Clear by this? Next one. ICl4, the shape is a square planar. The number of bond pairs, lone pair repulsions at 90 degrees they are asking. Clear now? See Mano, they have given ICl4 minus. ICl4 minus. Now bond pair, lone pair repulsions they are asking. First of all, they have given it is a square planar. Means how many bond pairs are there, how many lone pairs are there, you have to calculate. For that one I have given simple trick. Halogen, iodine means a halogen. Halogen means which group? 7th group means you have to write the 7 electrons. But negative is there. Negative means 1 electron you have to add. Means fluorine will form 1 bond only. To form 1 bond, iodine should give the 1 electrons to chlorine. Chlorine give 1 electron. Iodine should give 1 electron. 1 bond will form. And these we will call as a lone pair. And these we will call as a sigma bonds. And these 4 bond pairs are there. And there are 2 lone pairs. 4 bond pairs and 2 lone pairs. Then what is the shape ma? First hybridization, what is 4 plus 2? 6. sp3, p2. 3 plus 1, 4. 4 plus 2, 6. What is the shape here? Square planar. When 4 bond pairs, 2 lone pairs, square planar. Remember? So this is what is the shape of this molecule here? Square planar. This is a planar. So this is iodine, chlorine, 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 chlorine. This is chlorine, 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 chlorine. Here there is a lone pair and here there is a lone pair. Clear? This lone pair make a 90 degree with each the bond. Why? Because you see, this is simple. Just assume this is a square planar. 1, 2, 3, 4 square planar. Clear my this is. So here 4 bonds are there with the carbons. Like this they are 4 bonds. Clear? Now one lone pair is like this on the plane, above the plane, and another one is below the plane. Means this lone pair make a 4 means 90 degree with all the axes. Here this is making 90 degree here, 90 degree here. For this one also 90 degree. Clear man? So lone pair, bond pair, one lone pair and making a repulsions with the how many bond pairs? 4 bond pairs. These are we will call as a bond pairs. One lone pair making 4 repulsions with the 4 bond pairs, and here another lone pair is there. Totally how many one? This is also making and 90 degree with the 4 bond pairs, and this is will also make because this is above the plane. Below the plane also what is it will make this one and this all with the bond pairs 90 degree. So total how many lone pair bond pairs will be there? There will be a 8. Clear? So this is about. Next, arrange the following in the order decreasing NO bond lengths. NO2. Clear? First one they have given NO2 plus. NO2 plus. Clear? So this is the structure of NO2 plus. Clear? See now. Remember, I already said nitrogen has to form how many bonds? 3 bonds. If nitrogen forming more than 3 bonds, nitrogen should get positive. More means positive. Nitrogen is forming less than 3 bonds, on the nitrogen there should be a negative charge. Clear what is? See. Nitrogen is forming how many bonds? 1, 2, 3, 4. More than 3 means plus charge. If suppose if I write here NH3, NH3 means nitrogen is forming how many bonds? 3 bonds. We will not write any charge here. If suppose NH2 I will write, then I will have to put negative charge. Because nitrogen has to form 3 bonds, but here nitrogen is forming how many bonds? 2 bonds, so that's why negative. More positive, less negative. Same for oxygen. Oxygen has to form how many bonds? Oxygen has to form 2 bonds. If oxygen is forming more than 2, means 3 bonds, oxygen should get the what is positive charge. Clear? If oxygen is forming 1 bond, then oxygen has to get negative charge. Clear? Based on that, we have to write this structures. Clear? So this is NO2 plus. Next one is NO2 minus. This is nitrogen and 2 and here. This is nitrogen forming how many bonds? 3 bonds. So we will not write any charge. Oxygen is forming how many bonds? 2 bonds. No problem. But here oxygen is forming how many bonds? 1 bond only. 1 bond means oxygen is forming less than 2 bonds. There is a negative. This is clear. Next one. Next one is NO3 minus. This is NO2 minus. NO3 minus. This is I will write double bond O and I will put here negative 1 oxygen and another one is this is the oxygen on this one nitrogen hydrophobicity. Clear my dear? See, nitrogen is forming how many bonds? Check here. 4 bonds. So that's why here we have to write what? Which charge? Positive. Oxygen is forming how many bonds? 1 bond. So negative. This oxygen also forming what is 1 bond. So that's why we will write negative. But dative bond we are keeping. If we don't write dative bond, positive negative if you write, we will put positive charge on the nitrogen, negative charge on the oxygen. But if you write dative bond, we will not put any charge here. That is. Actually, we can write this in this way also. N double bond O and O minus and here O. Clear? This is the structure actually. Clear? Now, oxygen forming 2 bonds, no problem. Here oxygen forming 1 bond means less than 2, so less means negative. Here also negative. But nitrogen has to form 3 bonds. Nitrogen forming how many bonds? More than 3. Is a positive. Both are the same stage. Okay? Now they are asking what it is here. They are asking NO bond length. NO bond length means bond order you calculate, then bond order and bond length relation you already know. Clear? See now. Here what is the bond order? Here also nitrogen and oxygen. Nitrogen and oxygen. What is the bond order here? 2 bonds are there between the nitrogen and oxygen. Here also nitrogen and oxygen bond order will be what it is? 2 here. But in this case you see, in this one 2 and in this one 1. I already mentioned how to calculate the bond order. The total number of bonds between the atoms divided by resonance structures. Clear? So what is the bond order for this one? Bond order is equal to what it is? Total number of bonds between the atom. In this between the oxygen and oxygen 1, between the oxygen and nitrogen and oxygen 2. Total how much? 1 plus 2 divided by how many resonance structure you will get? This is means you can simply say if it comes here, it will go electrons here. Or otherwise simply, so 1 NO bond is there, another 1 NO bond is there. 2 resonance structures you will get. So 3 by 2, how much more here? 1.5. Clear? But my point here you see bond order. Bond order is equal to how much more here? And here, how many bonds are there between nitrogen and oxygen? 1 bond is there. Between nitrogen and oxygen, 1 bond is there. Between nitrogen and oxygen, 2 bonds are there. Divided by 1 NO, 2 NO, 3 NO. So that's the total how much one? 3. 3 resonance structures you will get if you write. Clear? Then 4 by 3, 1.33. Clear? You know that bond order is inversely proportional to bond length. So which one is having the lowest bond order here? And the NO3 minus is having lowest bond order. So in this case, bond NO bond length will be long. So that is your option should be what it is not here. Option means here it is having bond order. What is the order? NO2 plus is greater than NO2 minus is greater than NO3 minus. This is bond order. Bond length reverse. What is the reverse one here? NO3 minus is greater than, NO2 minus is greater than NO2 plus. This is the, so your option should be option 2 is the correct. Eighth question is irrelevant question, that is, so banana bond we will discuss. So there, and 14th group, 13th group we will discuss the banana bond, how it will be formed. Clear? So there we will discuss. Coming to the question number 9. What is the question number 9? You see, in which of the following molecule are ions? All bond lengths are equal. All bond lengths are what is known here? Equal. See over here. Si not equal, they are asking. SiF4, you know, SiF4. What is the hybridization over here? sp3. Clear? You know, SiF4 means carbon and silicon. Carbon forms how many bonds? 4 bonds. Silicon also forms 4 bonds. Will it have any lone pairs? No. So it is a regular geometry. Regular geometry means all bonds, bond length will be equal only. Clear? Next one. SF4. What is the hybridization for SF4? You see, SF4 sulfur. What is the sulfur? Sulfur belongs to cis group. Right, 6 electrons. Each fluorine need 1 electron to form a bond from the sulfur. How many bond pairs? 4 bond pairs. How many lone pair? 1 lone pair. 4 bond pair plus 1 lone pair. Total how much? 5. sp3d. 4 bond pairs. 1 lone pair. What is the structure? Seesaw structure. Seesaw structure means what it is, you will get the, and or you can say a trigonal. What is it here? Planar structure, not trigonal. Means trigonal bipyramidal. Trigonal bipyramidal means, you know, here there will be a lone pairs. Here sulfur will be there. Sulfur will be there here. And this is sulfur lone pair, fluorine, and what is it? Fluorine. You see, there will be a axial bonds and equatorial bonds. Axial bonds, what it is also can be called as a seesaw structure. Clear? What is here? Axial bonds are there, equatorial. This is, these are bonds we will call as what is one. This is equatorial bonds and axial bonds. You know that trigonal bipyramidal axial bonds are longer than the equatorial bonds. So that's why this SF bond, SF4, another one will be there. So this is fluorine. Clear? So in the SF4, yes, this sulfur and fluorine equatorial bonds are equal lengths, but these two are different lengths. So that's why option 2 is the correct one. Clear? Next one, 10th one. The hybridization and geometry of BRF3. Hybridization you have to calculate, and geometry also you have to say. What is the hybridization and geometry? Bromine belongs to which one? Right here electrons, bromine belongs to 7th group. So 7 electrons you write. Each fluorine need 1 electron to form a bond from the bromine. So how many lone pairs are there? 2 lone pairs. Here how many bond pairs are there? 3 bond pairs. 3 bond pairs plus 2 lone pairs. Total how many? 5. 5 means what is my sp3d. 3 bond pairs and 2 lone pairs. What is the shape? T shape. 4 bond pairs, 1 lone pair, seesaw shape, and 3 bond pairs, 2 lone pairs, T shape. So what should be our answer here? Option 1 is the